So we're going to test to see how likely 45% is based on our sample of 49 out of 140 household cats in the US hunt. So that's the hypothesis test. So again, we're going off this data here. We have a sample of 140 US households with cats. 35% of those cats, household cats, hunt. And now we're going to test that 45. So we're moving on for a hypothesis test with the central limit theorem. Now, last week when we were looking at hypothesis tests, we added the idea of, in addition to finding the p-value, we're going to find what's called the critical z-score, the standardized test statistic. Standardized test statistic. It's typically a z-score. And the z is the sample statistic minus the null hypothesis value divided by the standard error. Now, we have a standard error formula for proportions. That's what we're working with. So for proportions, this becomes sample statistic, that's our p-hat that we calculate. The null hypothesis, we usually just call that p. That's the value from the null. And the standard error for a proportion, since we're doing a hypothesis test, it centers on the null value. So that would be the square root of p times 1 minus p over n. Now, this is a little bit different than the confidence interval formula, and the reason is, again, hypothesis tests are focused on the null value. So this is slightly different than a confidence interval. Different since hypothesis tests center or focus on the null value. So it's similar. We have a p times 1 minus p. When we're doing a confidence interval, it's p hat times 1 minus p hat. Slight distinction we have to make to get this right. Let's try it for our current situation. So the question was, is it possible, plausible, that the actual proportion of US household cats that hunt is 45%? So question, is it possible that the proportion of US household cats that hunt is 45%? Question mark. So how does that lead to hypothesis? So here they use the word is, which is equal. So they're saying, is p equal to 0.45? Since there's an equals in there, this would have to be the null hypothesis. Now, for the alternative hypothesis, since just based on this question, I have nothing else to go on, I would say the alternative hypothesis would have to be that p is not 0.45. So I'm going to say those are my hypothesis. Note that makes this a two-tailed test. So from here, I want to calculate that standardized z-score. So the z-score, again, is going to be my sample statistic minus the null hypothesis value divided by the standard error. And for a hypothesis for a proportion, that's P times 1 minus P over N. My sample had N equal to 140, and P hat was given as 0.35. And so I need that information in this here. So let's see, P hat from the sample, 0.35. P from the null, 0.45, 45%. To calculate the standard error in the denominator here, I got to go back to the hypothesis test, not the sample. So this is a slightly different procedure than a confidence interval. So then I have that big old square root of, in this case, 0.45 times 1 minus that, which to be safe, you could just write 1 minus that, divided by, in this case, 140. And then we whip that out on a calculator or spreadsheet. I'll show how to set this up on a spreadsheet next time. I'm running out of time today. I'm just going to go to an ordinary calculator. Is most scientific again. So I got a big old fraction to do, 0.35 minus 0.45 divided by that crazy square root, which also has a fraction in it, 0.45 times parentheses 1 minus 0.45. And these modern scientific calculators are nice because they kind of put parentheses in for me where they probably should go. Okay, so I'm getting a z-score of negative 23785. 37835. Calculated that right. 37835. I didn't write it right. All right, so thinking about z-scores, if it's outside of 2 standard deviations, we consider that to be unusual. This is outside of 2 standard deviations. So thinking about a normal distribution here, z equals 0 is in the middle. 1, 2, 3 standard deviations out to the left. This one right here, oops, that's a negative 3, lives about right there-ish. And so then we have to use a normal distribution calculator to figure out what is that p-value. Since this is a two-tailed test, I need to double it out to the other side here. So I not only need to consider z is negative 0.27835, I also, because it's a two-tailed test, have to consider z equals positive 237.835. And with the theoretical normal, you can just double that one. So the p-value is both of these. And so I am going to use the spreadsheet for that right now. I'll show you more about the spreadsheet for this next class. So this is hypothesis test proportion. And I'm just going to do a quick p-value here. So in this case, to do a p-value, we use the norm.dist. Norm.dist says, give me your x value. Well, my x value is my z-score. So negative 2.37835 is the z-score I calculated. It's a z-score, so the mean is 0. Question, the 0.35 was given in the problem. We were told that 35% of US household cats in that survey hunted birds. From the previous example. 1, and then we always do a true at the end. So we did an example like this last time. Now, what does the normal dist in a spreadsheet calculate? It only calculates the left tail. So since this is a two-tail, I got to sneak in there 2 times that. So I'm getting a p-value of about 1.7% total. Back here. So my p-value with the 2 tails together is approximately 1.7%. If we go for the standard 5% significance level, this is significant. It would be unusual to find a sample of 140 household cats, of which 35% hunt, if we were expecting it to be 45. So is 45 reasonable? Not if my sample is good. So I would say reject the null, it's not 45. And I have evidence that's significantly less than 45 here. All right, we're out of time for fun with stats today. We will do more of this next class.